Okay, today's lesson is 3.3, Properties of Logarithms, and we are talking about something you did last year, so this should be really short and easy for you. So first off, remember that logarithms are just a fancy way of asking for an exponent of a number when you know the base of it. So for that reason, the properties of logs are tied very closely to the properties of exponents that you already know. So the first property of an exponent would be the product property, and that is when you multiply two expressions with the same base, what do you do to the exponents? You add them. So what our product property with logs says, when you have the log of a product, that's like adding the logs. So you can see there's a product, and here I'm adding the logs together. Similarly, when you have the quotient property, okay, if I'm dividing two expressions with the same base, then I subtract their exponents. So similarly with logs, our quotient property says when we have the log of a quotient, that is equal to the difference, or we subtract the two logs. And last but not least, we have the power property, and that says when you raise a power to a power, you multiply those exponents. So down here with logs, okay, that's what allows us to take this, should have done this ahead of time, this P here that y'all see so much and I kind of already talked about, and we get to take it down in front, which is what that's saying, is that we're multiplying the logs. Okay, so let's go look at the examples and see what you're going to have to be able to do. So first off, express each logarithm in terms of log 5 and log 3. So I need to figure out how to write 75 as a product of 5 and 3. Well, the easiest way to do that, you could break it down to its primes, since those are both primes, or know that 75 is like 3/4, so that means that you have 25 times 3, or 5 times 5 times 3. So when I write that, I'm going to write it as the log of 5 squared, because I have two 5s, times 3. So that is the log of a product, which means that I'm going to break up those factors and add them. So that's the log of 5 squared plus the log of 3. And when we expand with properties of logarithms, we cannot ever leave an exponent. So I have to remember to take that 2 down in front, which is going to give me 2 log 5 plus the log of 3, and that's it. Okay, 1b says the log of 5.4. So the easiest way here, class calc will do this for you, a lot of calculators will do it, would be to take the 5.4 and rewrite it as a fraction. If you don't know how to do it in class calc, please let me know and I will help you, but not during a quiz or test. So 5.4 is 27 over 5, and 27, you got to think about 27 is a power of 3, so that is going to be the log, because it's a quotient again, so 27 is 3 cubed, and of course I have 5 on the bottom. Now, because I have a quotient here, that means I'm going to subtract the logs. So I'm going to have the log of 3 cubed, which is on the top, minus the log of 5. Cannot leave an exponent. I got to move that down front, so that's going to become 3 log 3 minus the log of 5, and that's it. Okay, look at this next one. We've kind of already talked about this in our previous lessons, but kind of lets you know why it works what we did. So this first one, 2a, says log base 6 of the cube root of 36. So I'm going to have the log base 6, and I'm going to write 36 as 6 squared, and then the cube root, you know, because we've already had that several times, is the same as raising it to the 1/3 power. Okay, what do you do when you raise a power to a power? Well, that's going to be 2 times 1/3, which is 2/3, and that's the color of the White House, which is the odd man out. So the log base 6 of 6 to the 2/3 is 2/3. Now, you can see using our power rule, if I move that 2 down front, then the log base 6 of 6 is 1. So it's 2 times 2/3 times 1. Okay, look at this next one. We have ln of e to the 9th plus 4 times ln of e to the 3rd. So I can, in each case, move the exponent. So that 9 is going to go in front, and that 3 is going to go in front. So that means I'm going to have 9 ln e plus 3 times 4 ln e. Well, ln e, we've talked about that. When you see ln of e, that's inverse, composing inverses. So that's just 1, which means I'm going to have 9 plus 3 times 4, which is 12. And I'm going to have an answer of 21. And that's it. Okay, so look at these next ones. They get a little bit longer, okay? But I'm going to tell you something that'll make this a lot easier for you. But first off, when you look at something like 3a, it says log base 13 of 6a cubed bc to the fourth. Looks a little complicated, but all you have to do is determine how many factors you have. So how many different factors? I have a 6, and then I have a cubed, and then I have b, and then I have c to the fourth. So I have 4 different factors. And if I have 4 different factors, then that means I'm going to have 4 different things added together because it's all multiplying. So I'm going to have log base 13 of 6, and then I'm going to have 3 more, log base 13 of a cubed, log base 13 of b, and log base 13 of c to the fourth. And then I cannot leave an exponent, so I'm going to move the 3 in front, and I'm going to move the 4 in front, and that's going to give me, oopsie, log base 13 of 6 plus 3 log base 13 of a plus log base 13 of b plus 4 log base 13 of c. And that's it. Okay, look at this next one. We've got ln of 3y plus 2 over 4 times the cube root of y. Now, first off, a lot of people forget, but when you have a fraction like this, that fraction bar operates just like grouping symbols. So when you think of this, and this is a quotient, I have the top over the bottom. So it's going to be ln of the top minus ln of the bottom. Okay, I went ahead and put the cube root of y because I'm not writing it as y to the 1/3 because I can't leave it as the cube root of y because in essence it is an exponent. Okay, so on this next step, there's nothing that can be done with this because this is a sum. It is not a product or a quotient or a power. So it will carry down and be the same. But this next one, that is a product. So I've got to break up that product. And because it's a minus, then you need to think about the fact that you're going to have brackets and have to distribute that. So I'm going to break up my 4 times y to the 1/3 as ln of 4 plus ln of y to the 3rd because I have 2 factors. So however wish to think of it first, you've got to distribute the negative, and then you also are going to have to move that 1/3 down front. So I'm going to have ln of the quantity 3y plus 2 minus ln of 4 plus 1/3 ln of y. And that is all you have. Okay, now why does that bottom show up there? Because I want to point out to you that that part of it, that expression was on the bottom, y to the 1/3, 4 was on the bottom, and 3y plus 2 was on the top. So you really can, it will always work, y'all. That's why I'm telling you, and I think it makes it easier because a lot of people tend to make mistakes in all this. Whatever's on the top is going to be positive, and whatever's on the bottom is going to be negative. And if you can remember that, it makes going backwards a lot easier, which is what you have to do to condense, which is a very important concept. That's why we do all the practice of expanding so that you can condense properly, okay? Because that's what you're going to have to be able to do when we get into the next sections of solving equations. So on this first one, if you will look and see this first term, it says negative 5 log base 2 of x plus 1 plus 3 log base 2 of 6x. Well, since this first term is negative, it has to be on the bottom. And since this one is positive, it will be on the top. So that means I know I'm going to have division in my problem. Okay, when you condense, you are always condensing it to a single log. You only see the word log one time. Okay, and it doesn't matter the order, but I do have to remember that this 5 is going to be my exponent. So on the bottom, I'm going to have x plus 1 quantity to the 5th. And this 3 is going to be my exponent. And those parentheses are really important when you put the 3 there. And that is all you got there. So every time you look at some expressions with multiple logs in it, let's look at 4b here. ln of 3x plus 5 minus 4 ln x minus ln x minus 1. Okay, so I can go through all those fancy steps like I did backwards, or I can know this one's going to be in the top because it's positive. This one's going to be in the bottom because it's negative, and that one's going to be in the bottom because it's negative. And I have an exponent here that's going to have to become the exponent on the x. So single log, I'm bringing back together. Okay, on the top is 3x plus 5. And on the bottom, I'm going to have x to the 4th times x minus 1. And that's all she has. Okay, last thing, change of base formula. Okay, this is what it tells you. The log base b of x can be written as the log base a of x divided by the log base a of b. And basically that a is the base. You can rewrite a log in whatever base you want using this change of base formula. Now, why is it most helpful? Because way back when, before we had calculators with all these log buttons on it, okay, we had tables with what we called common logs, because common logs are those that are base 10. So to use my change of base rule, this is going to be the log of 4212 divided by the log of 78. Do not confuse this with a division of logs like we have 4, because we have 2 logs in there. Okay, and from there you would just punch it in your calculator if you want to do that, and you'll get 1.9156. That's all it is. Evaluate each logarithm. So log base 15 of 33 is going to be the log of 33 over the log of 15. So y'all, if you can remember, whatever's the bigger number goes on top, and the smaller number, which is kind of on the bottom, goes on the bottom. Okay, punch that in your calculator, 1.291. Over here, again, I'm writing the log over the log. What number's on top is 10. What number on bottom is 1/3. Okay, and when you punch that in your calculator, you get negative 2.0959. Okay, but what you need to know to do your homework in Delta Math, y'all, is really how to use the change of base formula. So what you need to know is I'm only asking you for this step in your homework problems. Okay, so make sure you write that down if you didn't print off the notes, that is the quotient of common logs. So I give you a problem and ask you to write me, express this log as the quotient of common logs, and this is the way you'll put your answer in. I already know you can do this on your calculator. So this is the important thing that you need to know how to do. And that's all she wrote. I hope that was easy for you. If you have any questions, don't hesitate to contact us or email us in any way. Thank you so much for watching, and y'all have a great day.